Hello there, welcome to CS School channel. In this video we are going to solve maximum subarray problem. This problem is asked a lot of time in different coding interviews. I have added link to this problem in the description of this video, so do check it out and try to solve it on your own. If you can't solve it, come back to this video. So now let's look at the problem statement. Given an integer array nums, find the subarray with the largest sum, and we need to return that sum. Okay, now what is the subarray? A subarray is a continuous non-empty sequence of elements within an array. Okay, so let's take example of this array. The subarray in this array can be -2, -2, 1, -2, -1, -3, -2, -1, -3, 4, right? Similarly, it could be 4, -1, 2, 1. Similarly, -1, 2, 1. Okay, so any non-empty sequence of numbers within an array, that's a subarray. So we need to find a subarray which gives us maximum sum, and we need to return that sum. Okay, so in this example, this is the subarray 4, -1, 2, 1, which gives us a maximum sum, which is 6. You try any other subarray in this array, it will not give you more than 6. Okay, similarly, let's take an example of this array. The array which is given to us has only one element, which is 1, and obviously that will be the maximum subarray sum in this array. Okay, similarly, let's take an example for this array 5, 4, -1, 7, 8. Okay, so if we found the subarray which has a maximum sum is this one, the entire array. Okay, so the entire array can also be a subarray of a particular array. So hope you are clear with the problem and some of its sample inputs and outputs. So now let's look at the first approach, which is the brute force approach for solving this problem. Okay, so in this approach, what we will do, we will generate all the subarrays, we will calculate its sum. If the sum is greater than some maximum sum variable, which we will store globally. If that is the case, then we will assign max sum with the sum value. So that's the overall intuition behind this algorithm. Okay, now let's see how this works. So in this algorithm, we start with the 4 variables. Max sum, which is initially assigned with 0. Okay, I, which is initially assigned with 0. Sum, in the first iteration it is assigned to 0. Okay, and j, which is assigned to I, which means it is assigned to 0. Okay, and inside this iteration what we do, sum is equal to sum plus nums of I. The value of sums is 0. I is pointing to this element in the array, so it becomes 0 plus -2, correct, which is -2. So sum has been assigned a value -2. So in this iteration, we have kind of generated an subarray with the element -2. Okay, so we check, is sum greater than maxsum? Maxsum is 0, sum is -2, right? That's not the case, correct? So we skip the assignment step, which is given here. Okay, then we increment j. So now j becomes 1. Okay, so that means we have included this 1 into our subarray now. So we are considering this element and we are including this element into the subarray, and then we calculate -2 plus 1, which gives us -1. Okay, is it greater than maxsum? Is the answer true? No, right? Maxsum is 0, sum is -1. Okay, so we skip the assignment step. Okay, and then we go to the next element, which is -3. Going to the next element means including that element in our subarray. Okay, and we go so on and so forth, and we calculate all the subarray which starts with -2, and then in the next iteration we assign sum to 0 and we start j from this one. So in the next iteration I will start from here and j will start from here, so it will create all the subarray which starts with 1. Okay, it's like 1, and in the next iteration we will create 1 -3, so on. We will create 1 -3, 4. Okay, so on and so forth. We will create all the subarrays again. We will calculate the sum. Any sum is greater than maxsum, we will assign maxsum with the sum value. Okay, and so on and so forth. So hope you got the intuition behind this approach. Now let's look at time and space complexity of this approach. Well, what is the time complexity? See, we are running 2 for loops which are going from 0 to n-1, and this is going from I to n-1. Okay, so kind of we are running 2 for loops over the array, which gives us O of n square time complexity. And what is the space complexity? As we are not using any extra space other than this maxsum, okay, the space complexity becomes O of 1. So hope we are clear with the brute force approach of this problem. So now interviewer will certainly ask you to do better than your previous approach. Okay, so what we can do, Well, to think about what we can do better than the previous approach, we need to see some of the sample inputs and outputs. So consider this example array 1. Okay. So what is the maximum sum subarray in this array? Well, it's 1 only, as there is no other number. So right. So the maximum sum is 2 and the maximum subarray is 1. And now what will happen if we add 2? The maximum sum subarray will now be 1 comma 2, right? As 2 is added and it is a positive number, we should consider that in our sum, right? And the sum becomes 3. Okay. What will happen if we are given an array 1 comma 3 comma 4? Certainly the maximum sum subarray will be that same array, because all the numbers are positive, right? And it will only increase our sum. So the sum becomes now 1 plus 3 4, 4 and 4 8, right? Now consider this example 1 minus 3 2. Okay, so now what will the maximum sum subarray? Think about it. So now let's look at some of the subarrays. The first subarray which we can produce in this array is 1, right? So the sum becomes 1. Then we produce 1 minus 3. The sum becomes minus 2, not greater than 1, right? We can produce 1 minus 3 2. The sum becomes 2 plus 1 3 and minus 3 0, right? And we can have another subarray which is only 2, right? So the maximum sum subarray in this case becomes 2, right? With the sum as 2. Cool. Why that's the case? Because 1 is producing 1. If we add minus 3 in any subarray, it is giving us a negative result. Even if we consider minus 3 2, it becomes minus 1, right? So 2 is the only element which is giving us a positive result. Okay. Now let's consider this example. We have added 4 in the above array. Now what will happen? 1 is not the right answer, right? If we added 2, we can consider this subarray to be the maximum, because 4 is positive, right? 2 comma 4. That could be a maximum subarray. And the sum which is given to us is 6. If we include minus 3, it becomes way less negative. If we include 1, it becomes minus 3 plus 1 minus 2. So minus 2 is added into this sum which gives us 4. Okay. Now consider this example. Here what we have done, we have made 2 as negative only and added 5. What will be the maximum sum subarray in this case? So answer is obvious. The subarray with the elements 4 and 5, right? So it becomes, the sum becomes 9. Why? If you add 2 minus 2, it becomes negative. If you add minus 3, it becomes more negative. And if you add 1, it becomes slightly positive, but still negative than the overall 9 element. Now let's take a next example. Here we will start with 3. The first subarray which we can create is with 3, right? The second subarray which we can create is 3 minus 2, which is 1. Okay, not greater than 3, right? Then the next subarray which we can create is 3 minus 2, 2, which becomes 3. Okay, not greater than 3, but it's equal. The next subarray which we can create is 3 minus 2, 1, which gives us the sum of 4. Okay, and then next subarray is 3 minus 2, 2, 1, 5, which gives us the sum of 9. Okay, so if you try to create all the subarrays, you will get that this is the maximum subarray which we can create with a maximum sum. So let me just write down the sum as well, which gives us 9. Now if you look at here, we are also considering this negative 2. Why we are considering that? If you create this subarray 3 minus 2, it gives us 1. So 1 is a positive number, right? And if you add all the positive numbers in that positive number, it will create a bigger positive number. In this case, what was happening? We added minus 3 to 1. It was giving us a result of minus 2. And if you added any positive number in this negative 2, it would have given us a smaller positive number, right? Similar was the case here. So if you want to consider negative number in our subarray, we need to make sure that the sum which is created by that negative number should be positive. Then and only then we can consider that subarray in our final result. Consider this last example. We will start with 1. We will check 1 minus 3 is minus 2, right? So we can discard this entire subarray as it is giving us a negative number, right? Then we can start with 2. 2 plus 4 is 6, right? And then we are adding minus 7 into it. Again, it is creating minus 1 as our subarray. So discard this subarray again. And then we reach to the 8 and 9. We can add those. It is giving us a positive result as both the integers are positive, right? So 9 plus 8 becomes 17, right? So 17 is our answer. Okay. So basically, whenever our sum becomes negative for any subarray, we discard the subarray entire and we start considering subarrays from the next positive integer. So hope you got the intuition behind this solution. Now let's look at the algorithm for this same intuition. So the algorithm which we have just seen is called as cadence algorithm. So let's look at this algorithm and let's iterate over the array to see what happens in each steps. In this algorithm, we initialize two variables. First variable is answer, which we have initialized with int min. In C++, int min means the minimum integer which is possible. Then we have another variable called as max ending here. This variable will just calculate the current sum in the array, and if it is 0, we will reset that sum and start with the new subarray. After that, we have written a for loop which will go from 0 to the size of the array. We will start adding each element into the max ending here. Okay, and we will check if answer is less than max ending here, then we assign answer with the max ending here. If the max ending here is negative, that means we need to start a new subarray. In that case, we just reset the max ending here with 0, and at the end we just return the answer. So let's see the iteration of this algorithm step by step. So the input which is given to us is shown here. Firstly, we have initialized answer with int min. I have considered int min as a number which is way negative, like -999. Okay, and the max ending here is initialized with 0. Then we are running a for loop with I initialized to 0. Okay, so now let's look at what happens in each iteration. As the first step, we are adding max ending here with the nums of I is pointing with this -2, so max ending here becomes 0 minus 2, which gives us -2. Okay, then we check if answer is less than max ending here. Well, answer is 999 and max ending here is -2, right? So we assign answer with max ending here, so answer becomes -2. Okay, and then we check if max ending here is less than 0. Well, that's the case. Max ending here is -2, which is less than 0. Then we assign max ending here with 0. Okay, then in the next iteration we start considering this element. Again we calculate max ending here, so max ending here becomes, so currently it is 0 plus nums of I. Nums of I is 1. Okay, then we check if answer is less than max ending here. Answer is -2 and max ending here is now 1, right? Then we assign answer is equal to max ending here, so answer becomes 1. Okay, and then we check if max ending here is less than 0. Well, that's not the case. Then we move on to the next iteration. So we start considering -3. Okay, now we calculate max ending here again. It becomes 1 plus -3, which gives us -2. Okay, then we check if answer is less than max ending here, where answer is 1 and max ending here is -2. That's not the case, right? And then we check if max ending here is less than 0. Well, this is the case, right? Then we assign max ending here with 0. Okay, so that means in this subarray we are getting negative as our result, right? So we are discarding this subarray, and then we will start fresh with this next set of subarrays. Then we increment I. So we calculate max ending here. It becomes current max ending here, which is 0 plus nums I. Nums I is 4. Okay, so it becomes 4. So we assign 4 to the max ending here. Then we check if answer is less than max ending here. Well, that's the case. So we assign answer with the max ending here. Then we check if max ending here is less than 0. Well, that's not the case, right? And then we increment I again. So we start considering this -1. Now what we do, we calculate max ending here again, right? So it becomes 4 plus -1, which is equal to 3. So is answer is less than max ending here? Well, answer is 4 and max ending here is 3. So the answer is not less than max ending here, right? Then we check max ending here is less than 0. No, max ending here is not less than 0. Then we increment I again. So now I becomes this. Then we calculate max ending here. So it becomes current value of max ending here, which is 3 plus 2, which gives us 5, right? So we assign 5 to the max ending here. Then we check if answer is less than max ending here. Well, that's the case, right? Answer is 4 and max ending here is 5. So we assign 5 to the max ending here. Then we check if max ending here is less than 0. Well, that's not the case, right? Then we go to the next iteration and we start considering this one. Okay, so max ending here becomes 5 plus 1, which is equal to 6. So we assign 6 to the max ending here. We check if answer is less than max ending here. That's the case, right? So we assign 6 to the answer as well. And as max ending here is not less than 0, we go to the next iteration and we start considering this -5. Now we add this -5 to the max ending here. So it becomes 6 plus -5, which is equal to 1. So we assign 1 to the max ending here. So is answer less than max ending here? No, that's not the case, right? And neither the max ending here is less than 0. So we go to the next number. Now we calculate the new max ending here, which is 1 plus 4, which gives us 5. So we assign 5 to the max ending here. And is answer less than max ending here? No, that's not the case. Neither max ending here is less than 0. Okay, so finally we return answer, which is 6. And if you remember, the sub array which gives us the 6 answer was this one, 4 minus 1 2 1. So hope you are clear with the step-by-step iteration of this algorithm. So what's the time and space complexity of this solution? Well, as we are running only one for loop over the input array, the time complexity becomes O of n. Okay, and as we are not using any extra space, the space complexity becomes O of 1. So now let's look at the C++ implementation of the algorithm. So we need to complete this max subarray function, which takes vector of integer as an input and it expects maximum sum integer as an output. Okay, initially we have initialized answer with int min and max ending here with 0. Okay, after that we have run a for loop. We have calculated max ending here. We have checked if answer is less than max ending here. If that is the case, we have assigned answer with the max ending here. If max ending here reaches negative, we have assigned 0 to the max ending here, and at the end we have returned the answer. So this code is just like an algorithm which we have seen. So now let's run this code. For running this code, I have written a main function. In this function, I have declared a nums array. I have passed that nums array to the max sub array function, and whatever the result which is returned by the max sub array function, I have printed it onto the console. Okay, so let's run this code and see the output. So the output is 6, which is our maximum sum of sub array. So hope you are clear with the problem and its solution. If you have any question, do ask me in the comments below. I will be more than happy to help you. We will be making more such videos in the future. So do subscribe to our channel and stay tuned for further videos.